Hi guys, I'm gonna have to speak a little bit softer now because people are sleeping. Okay, so here we go. We have this thing here. We want to lift this satellite, whatever it is, 800 miles above the Earth. Okay, and the exercise asks for the amount of work that's gonna be done. But here's the thing. It says that the satellite weighs 15 metric tons. I'm just going to say 15 tons, but you got to know that's not English, it's metric. 15 metric tons at the surface of the Earth. Okay, so you got to remember about it's not Hooke's law, it's Newton's gravitational law. This is a mess, and the planet is a mess. Okay, so remember that formula that you have force equals K mass 1 times mass 2 divided by the square, the distance between them. Well, it says that this weighs 15 metric tons. So I'm just going to put 15 tons, okay, equals. I don't know what the mass of these things are. And it doesn't matter because the K is not going to change, the mass of the Earth is not going to change, and the mass of the satellite also is not going to change. The exercise is asking to don't consider the change in the weight of the satellite as it expels fuel, okay? Because as it burns fuel and exhausts the gas, it's going to become lighter and lighter and lighter. But forget about that. Just pretend that the mass of the satellite is steady. So K is constant, the mass of the planet is constant, and the mass of the satellite is also supposed to be considered constant. So I'm just going to put a constant here. And it says that it's at the surface of the Earth. So you got to measure that thing from the surface all the way to the core, which is 4,000 miles. So you put 4,000 here. Okay. Let me just see one thing. Yeah. It'll be 4,000 squared, right? So multiplying this, obviously I'm copying this from the book, it's going to be 240 million. Like that, okay? So if C is 240 million, I can just say that F equals 240 million divided by x squared. This is going to be the function according to the distance from the core, okay? So here's the thing. You want to move this stuff 800 miles away from the Earth, okay? This, there's something else that I want to explain to you guys. I want to make a parallel here or a parenthesis here. Let's just say that you're talking about space, okay? You have space. The derivative of space with respect to time is going to be the velocity, okay? That means that the derivative of space equals the instantaneous velocity times dt. If you integrate this stuff, what are you going to get? This equals the total space, okay? Now think about force, displacement, or distance, and the work. The derivative of the work with respect to the displacement, I'm going to put displacement as x in here, okay, equals the instantaneous force. So the derivative of the work equals the force times the derivative of the displacement. I want to make an analogy between this and this. So if you integrate this stuff, what's it going to be equal to? The work, okay? Exactly what I did in here, I did in here, and exactly what I did in here, I did in here, right? Just for you guys to understand. So this is the immediate function, right? Being this the immediate function, the instantaneous function, because here we have an instantaneous velocity and here we have an instantaneous function. So having an instantaneous force, sorry, not function, having an instantaneous force. Having an instantaneous force and multiplying it by dx, this is going to be equal to the derivative of the work. Okay? Because you see, look at this. Here you have an instantaneous force, here you have an instantaneous force. When you multiply by dx, what do you have? You have the derivative of the work. So when I'm multiplying this here by dx, I have now this is the derivative of the work. If I integrate this stuff now, I integrate here, okay? What do I have? I have the work, okay? Now it's a little bit easier to understand. Okay. All right. So you have this stuff in here now. It's going to be 240 million times x to the minus 2. So you make this become x to the minus 1 and divide by minus 1. So this is going to be equal to the work, okay, which equals minus 240 million divided by x. And you want to integrate this stuff from 4,000 to 4,800. Why 4,000? Because at the surface it's already 4,000 miles away. 4,800. Okay? So you integrate this. Not integrated because it's already integrated. You just plug in from 4,000 to 4,800. Now when you do that, I'm going to come over here now. It'll be minus 50,000 plus 60,000, okay? Which equals 10,000. 10,000 what? 10,000, and then you got to use the force, right? Which is the metric ton times the miles. So it's 10,000 metric ton miles, okay? I'm just going to say ton miles. That's what it takes to get the satellite over there. Actually, it's going to take less than that because, like I said, the satellite's very heavy in the beginning because it has a lot of liquid fuel. But as the fuel's burned and you have an exhaust gas being expelled from the back of the satellite to propel it forward, the satellite's going to get lighter and lighter. So you need less and less. We're going to see an example of that later, okay? But for now, this is the final answer. 10,000 metric tons miles are going to, 10,000 metric tons miles is going to propel the satellite from the surface of the Earth to 800 miles. Okay. Now we got another example here. All right. This is the illustration. Okay. So what's the story here? Well, this is a spherical oil tank. I'm going to do this because it's easier to see the stuff with this, I guess. I don't know. But anyway, this is a spherical oil tank that's filled up to the half, okay? And what you want to know is the force that it's required to get all this oil out of here. Not the force, but the work. Now, this is going to depend on the radius of the top of each one of these rings, because you see what you have. Okay, let's start the story again. You have a spherical tank, okay, that's filled up to the half, and you want to know the work to get all this oil out of here. Well, you're gonna split. You see this red part in here? you're splitting. This is just an illustration of how to split this oil into infinitely thin discs, okay? So you're gonna get the top disc, and the other disc, and the other disc, and the other disc. So you're gonna calculate the work to get one disc out, and to get another disc, and to get another disc, and to get another disc, right? Just in your mind, slice this oil here in very thin discs, and you're getting one disc out and another disc out. Now, here you have something, for example, what is the work, right? Work equals the force times the displacement or the distance. Well, the distance is not going to vary. The distance is going to vary because the top disk is closer to the end. Okay, this end right here. This top disk is closer to this end here than a disk down here. You see a disk down there, and then you have some disk down there, and then you have a disk all the way at the bottom. So the closer to the bottom, the higher the distance to go to the top. All right, that's number one. Another problem is that the force is also not going to be fixed, because the force is going to depend on the weight. Now, if you have a larger disk, it's going to weigh more. If you have a smaller disk, it's going to weigh less. Okay, so the force is going to vary, and the dislocation of each one of the disks getting to the top of the tank is also going to vary. Let's do that. Okay, the exercise states that the radius is 8 feet. Okay, so the radius of the thing here is 8 feet, is half full, and the oil weighs 50 pounds per cubic foot. So 50 pounds, if you don't know, is a measure of force. So you have a force density, because usually in physics, density equals mass divided by the volume. Well, in this case, you have the force, okay, not the mass. You actually have I'm going to put the force in here, which is going to be the weight. So you have this stuff, all right? If you want to know the force, you have to do force equals the density, the force density times the volume, all right? Now, let's check this out. What did the thing say? The force in this case, guys, is the weight of the disk, right? How do you calculate the weight of the disk? Well, it's going to be the density times the volume. So what is the density? The density is 50 pounds per cubic foot. So force is going to be equal to 50 pounds. I have some neighbors here that are making a lot of noise. 50 pounds per cubic foot. So if I have to now multiply the volume, okay, how do I get the volume? The volume is a three-dimensional unit, okay? You have something in here, you have something in here, and you have something going up like that, okay? So what's going to be the volume? It's going to be the area of the disk in an infinitely small thickness, okay? What's going to be the area of the disk? Well, it's going to be pi x squared, because you see that the x is over here. Here's the y, okay? And this is the x. So actually the radius is in x. So it's pi x squared, right? That's fine for now, pi x squared, times dy. Why dy? dy is the infinitely small thickness. Now, you have something squared here, we're talking about dimensional analysis, times another dimension, which is y. In the end, this becomes cubic, okay? And that's the volume, it's cubic feet. Okay, so you have that in here, but so I'm going to put pi x squared dy. But here's the thing. I cannot, if I'm going to integrate with respect to dy, I cannot have x in here. I have to show x as a function of y. Can I do that? Yes. Because you see, the bottom of the tank is considered to be a coordinate at the three-dimensional coordinate 0, 0. Okay, so let's talk about this. Well, we're going to talk about a radius. Okay, a circle radius 8 and center at 0 and 8. So I don't know if yeah. So it's considering a circle, okay, of radius 8 at center 0 and 8. Okay, it's going to be this circle right here. So let's see. If you want to make a circle, I don't know if you remember the equation of the circle. It's going to be x minus x0 squared plus y minus y0 squared equals the radius squared. Well, the radius is 8, okay, because the tank has radius 8. So this is going to be 8 squared in here. The circle is centered at 0, so this is going to be 0. Okay, so it's going to be x squared plus, over here we're going to have y minus 8 squared, because the circle is centered at point 0, 8. So this is the equation, right? So what is x squared? X squared equals 64. And then you have the minus this stuff in here squared. I'm already going to do that. This is going to be y squared, but going to the other side becomes minus y squared. And then you have minus 16, but going to the other side becomes plus 16y. Okay, minus 16y becomes plus. And here you have a plus 64. Going to the other side becomes a minus 64. This 64 is cancelled with this, and this is x squared. Now you have x as a function of y. Okay? So I'm going to get this thing out of here. I'm going to get the x squared out, and I'm going to bring this stuff. And I'm going to bring this stuff in. Well, actually, I'm going to factor the y out, okay? Should I do that? Nah. Because it's multiplying. Whatever. So it's going to be minus y squared plus 16y, okay? And now you have the dy. This is going to be the force that is required for each one of these circles to come, right, to go up. Now we have to talk about the distance, because remember, for the work equals the force times the distance. Well, this is the force, but now you have to worry about the distance, because each one of these circles in here is going to have a different distance. Okay, this one is closer to the top. This one right here is further from the top. So when, for example, this is the top, okay, which is 16 in y. This is the top of the tank, which is 16 in y. All right, and this is the bottom of the tank, which is 0. And here you have whatever. Now let's just say that you have a circle that's here, okay? It's going to be probably this red one in here. What is going to be this distance? Because that's the distance that it has to go. It's going to be 16 minus y, okay? This circle right here is at a height of y. So what is going to be the distance that it has to go? 16 minus y. So we're going to put that in here too, because this is the force. Okay. Now, what I'm going to do, 16 minus y, right? That's the distance. So you do the integral of 50 pi, I'm just going to copy this, times minus y squared plus 16y, okay, times what? 16 minus y, remember, which is the ddistance, dy. Okay, I know it's complicated, but that's it. All you gotta do is finish it. Will be the work, okay, to get all this oil out of here. Oh, the 50 pi, okay, this equals 50 pi is a constant with respect to y, so I'm just gonna put 50 pi times the integral. Now we gotta multiply all this stuff in here, so I'm gonna do that. It's gonna be let's start with it'll be y cubed. In order to get a y squared, you have minus 16y squared minus 16y squared, so minus 32y squared. To get a y, no, you can't get a y, it's impossible. That's it. Oh no, you can get a y, you can. Plus 256y. Okay, so to get the y cubed, you multiply these two. To get the y squared, you multiply this and you add by multiplication of this, and to get the y, you get this. So I'm gonna put this in here and the dy. All right, this equals 50 pi, right? And now we do that. Oh yeah, and the integral, guys, is from 0 all the way to 8. Okay, because the tank is half full, y ranges from 0 to 8, and the work required to empty the tank is, that's it, this integral is going to go from 0 to 8. Why aren't you using more? For example, how about 0 to 16? But we're talking about the work, and the thing is half empty. Okay, so you don't have any work to get oil from 12 to 16, because there is no oil from 12 to 16. It's just from 0 to 8. Okay, so 0 and 8, and a 0 and an 8. So it'll be y to the 4th divided by 4 minus 32y cubed divided by 3 plus 128y squared. Okay. Now, all you gotta do, guys, is plug in the values, okay? Since you have y everywhere, you don't have to worry about the 0. So let's do that. Well, it'll be 50 pi times. Here you're gonna have 2 to the 3rd, which is 8, to the 4th. Yeah, it's gonna be 2 to the 32. Yeah, man, this is big, man. It's gonna be 2 to the 3rd, yeah. You're elevating that to the 4th, so it's 2 to the 12, yeah, sorry. Went a little bit crazy now. So it'll be 2 to the 12. But you see, what happens is that, what is 8? 8's 2 to the 3rds, okay? 2 to the 3rds to the 4th, so this is gonna be 2 to the 12th, divided by 2 squared, 2 to the 10th. And 2 to the 10th is 1024. All right. and then you have minus, so you're going to have a cubed minus 32 divided by 3. Let me see that. 64 times 8 times 32 divided by 3. Yeah. I'm going to leave that 3 for now. So it's going to be minus 16,384 divided by 3, because it's not exact, guys. And then you have an 8 in here, okay? So 8, 2 to the third squared, it'll be 2 to the 6th times 2 to the 7th. It's 2 to the 13th. Now 11 is 2048, 12 is 4096, 13 is 18192. So this is going to be 8192. Some crazy mathematical things that I do in here. All right. And now you got to do all these things. So this here is going to become equals 50 pi, and I'm going to put a 3 here, okay? This is going to be 3072 minus 16,384 plus 6, 3 and 2, 27, so 7 goes to 3 and 1, 2, 3 and 1, 3 and 2 of 5, and this is going to be 24, so 24,576. I think I'm right. 8,192 times 3. Yeah, 24,576. Now minus 16,384 minus 3,072. Okay, so this whole thing is going to become 5120. This is 50 pi times 5120 divided by 3. Let's do that. Divide this by 3 times 50. I'm gonna say times 3.14. Got 267, blah blah blah. I think that I made a mistake somewhere. Let me see. I'm gonna try to. Oh yeah. Let me see. 12 to the 10th, 1024 minus 32y cubed divided by 3 plus 1000. Da, da, da. Let's see here. 64 times 128. Yeah, that's right. And now have 64 times 8 times 32. No, that's right. I don't know where I'm going wrong in here. This is right stuff. I don't know what happened. Anyway, or maybe the book is wrong, you know. Yeah, maybe the book is wrong, because I don't think I made any mistakes. Let's see. How do I erase this stuff? Okay, so 10,024 plus 8192. Okay, because here I took the minimum common denominator. Let's try that again. 3,072 minus 16,384 plus 24,576. Oh, okay, now I got it right. Yeah, now I got it right. Anyway, let's just keep going. So you have that, okay, so this is gonna be, actually guys, I made a mistake in here. Adding all these things up, you have 11,264 in here. 11,264 in here, okay? Now you do 11,264 times 50 times 3.14 divided by 3. Yeah. In the end, you have 589,000, okay? 482 point, and then it goes 6, 6, 6, and it just keeps going. I'm gonna put the 6, and I'm gonna do this, I guess, to indicate that it's a periodical thing, that it goes 6, 6, 6, 6, 6. So 589,482. What's gonna be the unit? Well, the unit, we're talking about really feet in pounds, so it's gonna be pounds feet. It's weird, but that's the unit of work. Okay, pounds feet, or foot pounds, right? That's what they call foot pounds. Foot pounds. Yeah. That's it.